In 1942, the Atlantic was a graveyard. German U-boats hunted in wolf packs, ripping holes in the Allied lifeline. Merchantmen burned on the horizon. Cargo slipped under cold waves. The math was brutal. Britain needed ships faster than the enemy could sink them. Washington made a radical bet. Build simple, build fast, build thousands. Ring the coast with yards, light the night with welding arcs, train newcomers in weeks, not years. The result wouldn't be elegant or quick. It didn't have to be, it just had to arrive. They called it the Liberty ship. Plain, boxy, loud, but it was a weapon made of schedule and steel. In late 1941, the U.S. Maritime Commission handed industry a blunt brief. Stop chasing elegance and start shipping steel. The new cargo ship would be cheap, rugged, and fast to fabricate. Engineers pulled an old British cargo design off the shelf and stripped it to the essentials. The result got the code EC2-S-C1. Emergency cargo? About 440 feet long, steam-powered, welded, not riveted. No exotic alloys, no precision turbine gears. A triple expansion steam engine, Victorian in spirit, meant any competent foundry could cast parts, and any yard could install them. Franklin Roosevelt jokingly called them ugly ducklings. But that was the point. Beauty takes time. Prefabricated sections would be built indoors, rolled to the ways, and stitched together. Every dimension was standardized, every bracket numbered, every job broken into repeatable steps. The order was simple. Build them everywhere all at once to a timetable the enemy couldn't match. Speed wasn't a perk, it was the weapon. The Liberty ship's code looks cryptic. EC2-SC1. It's just a shorthand. E equals emergency, built fast. C equals cargo, not combat. 2 equals size class, about 400 to 450 feet at the waterline. S equals steam-powered. C1 equals the specific hull plant design. In plain English, a medium cargo ship you could build anywhere quickly. Specs simplified, about 441 feet long and 57 feet wide, with 5 cargo holds and 11-knot top speed. Typical load was around 9,000 tons of cargo, food, trucks, shells, fuel, moved by the ship's own derricks and steam winches. Power came from a triple expansion steam engine. Sturdy, slow, fixable in the field. Crew ran roughly 50 to 100 people, mixing merchant marine civilians with a Navy armed guard for guns and radios. From Maine to California, the U.S. ringed its coasts with Liberty ship factories, 18 major yards acting like one giant assembly line. On the West Coast, Kaiser's Richmond complex and the Portland yards pulsed day and night. Down in Los Angeles, Cal ship fed the Pacific lanes. Across the continent, Bethlehem Fairfield in Baltimore, North Carolina Shipbuilding in Wilmington, and New England Shipbuilding in South Portland hammered out hulls for Atlantic convoys. Each yard followed the same playbook. Identical jigs, identical parts, identical sequences. Railroads funneled plates, castings, engines, and winches to the slipways. A new keel went down as another hull slid into the water. Fitting out piers finished yesterday's launch, while shops welded tomorrow's modules. Launch calendars looked like production spreadsheets. Names assigned, christenings booked, crews queued. It wasn't one shipyard beating the U-boats. It was a synchronized network, timed to the hour, turning a continent's industry into a single machine that delivered steel on schedule. Riveting made sense when you were building a few ships a year. It collapsed when you needed thousands. The Liberty program switched to prefabrication and welding. Instead of building a hull like a hand-sewn suit, yards made it like a kit. Hundreds of plates and frames cut indoors, curved on presses, drilled, and staged on dollies. Crews assembled big modules. Bow sections, stern sections, deckhouses, even entire cargo hold boxes. Those modules rolled to the slipway, dropped into place by cranes, and were welded into a single hull. Welding was faster and lighter than millions of rivets, and it needed fewer highly specialized workers. The sequence was clockwork. Lay the keel plate, stand the transverse frames, add the double bottom and bulkheads, close the shell with pre-shaped plates, set the deck, lower in the engine and boilers while electricians and pipe fitters chase you with miles of cable and pipe, then launch and finish at the fitting out pier. Early builds took months, practice turned months into weeks. At the peak, a new Liberty was sliding down the ways every few hours across the country. One publicity sprint, the SS Robert E. Peary, went from keel to launch in under 5 days. Proof of what the method could do. The secret wasn't only steel, it was people. America didn't have a spare army of ship fitters in 1941, so the yards made one. High schools turned into welding classrooms. Parking lots became mock-up decks. Trainers broke every task into repeatable motions. Tack here, stitch there, pass the torch, inspect. A rookie could be useful in weeks. For the first time, shipyards hired women and large numbers of minority workers at scale. Crews on the ways were a cross-section of the country. Dust Bowl migrants, farm kids, veterans of the Depression, mothers stepping into paid industrial work. Around-the-clock shifts needed support, so forward-thinking yards built cafeterias, daycare solutions, and on-site medical clinics to keep people healthy and on the job. The culture shifted from craft to team sport. If a module arrived late or out of tolerance, everyone felt it at launch. Progress boards tracked every weld, every pipe run, every inspection stamp. Paychecks and pride rose with the launch rate. The result wasn't just more workers, it was a learning system that got faster, safer, and smarter with every hull that slid into the water. A Liberty ship started long before the keel plate touched the ways. Steel mills rolled plate inland, foundries cast engine parts, rail yards staged boilers, winches, anchors, and miles of pipe. Freight cars arrived like clockwork, each loaded to match a build sequence. If a crate was late, you didn't just lose a day, you risked missing a launch window. Inside the yard, the choreography was tight. Plates were cut and curved under roof, frames stood on jigs. Bulkheads were outfit with ladders and lighting before they ever met the hull. Cranes fed the slipway like a buffet line. Bow module, shell strake, deckhouse, funnel. Inspectors shadowed every crew, stamping welds and pressure testing lines, so rework didn't boomerang later. After launch, the ship slid to a fitting-out pier where radar, radios, lifeboats, and guns went aboard. Stores crews packed holds with dunnage and lashings. Riggers tuned derricks and winches. The engine roared on bunker oil for the first time. Only when every checklist box was inked did the harbor tug pull her into the channel, one more hull joining the lifeline. Speed exposed weaknesses. Early in the program, some welded hulls developed brittle fractures with dramatic cracks racing across plates in cold seas. The headlines were scary, the fix was science. Investigators tested steel samples at different temperatures and notch shapes, learning that certain steels turned glass brittle in North Atlantic winters. Welding wasn't the villain alone. The materials and details were. Standards changed fast. Yards added crack arresters, short runs of rivets or doubler plates that forced a fast-moving crack to stop. Corner cutouts got generous radii. Weld procedures tightened, better preheat, cleaner bevels, more inspection. Steel specs shifted toward tougher grades with proven low-temperature performance. Training emphasized joint prep and sequence, so residual stresses didn't stack up. Within months, fracture incidents plunged. The lesson outlived the war. Toughness matters, details matter, and the right fix is rarely slow down. It's learn, adjust, and keep building. The program's ability to correct course under pressure was as impressive as its launch rate. The German plan was arithmetic: sink merchant ships faster than the Allies could replace them. The Liberty program answered with bigger arithmetic. As 1943 wore on, the balance flipped. Convoys grew denser. Long-range aircraft closed the air gap. Radar, HF/DF, and better escort tactics squeezed wolf packs. But even with those gains, mass mattered. A convoy that loses 3 ships but delivers 50 still feeds Britain, Russia, and North Africa. Liberties became the bulk carriers of victory. Grain, fuel, trucks, locomotives, rails, bombs, crated fighters. Everything a modern army burns through by the hour. Their 11 knots weren't glamorous, but their predictability was lethal to the U-boat strategy. Success revealed limits. Convoys moved, but 11 knots left little margin. The answer was the Victory ship, a refined, faster successor with a sleeker hull, more power, and higher cruising speed. It carried a similar payload, but shaved days off long routes and handled rough water with more grace. Victories didn't replace Liberties overnight. They complemented them. The backbone stayed the same. Prefab blocks, standardized gear, learned routines, only tuned for speed. By late war, the two types were sailing side by side, one proving that simple, repeatable production could win a logistics war, the other showing how that method could evolve without breaking the system that made it possible. And you can't build thousands of ships with handshake deals. The U.S. Maritime Commission used cost plus fixed fee contracts. Yards recovered allowable costs and earned a set fee, with bonuses for beating payer days and penalties for missing them. That structure did 2 things. First, it de-risked the learning curve. Nobody had to guess the cost of welding a ship faster than history had managed. Second, it aligned the scoreboard. Time. Schedules ran like production lines. Every hull had a calendar: keel date, launch date, pier days, sea trials. Vendors got need-by dates that matched those milestones. When a shop cut average weld time or a supplier shaved a week on boilers, the whole network felt it. And the yard's bonus line did too. Wartime spending was massive, but it bought something permanent: a national playbook for building complex things fast. Most liberties went for scrap after the war. A few served for decades in merchant fleets or as reserve hulks. Today, 2 survivors still steam under their own power: SS Jeremiah O'Brien in San Francisco and SS John W. Brown in Baltimore. Step aboard and you can feel the design choices in your bones. Tight ladders, honest welds, the thrum of a triple expansion engine pushing a ship that once crossed U-boat waters at 11 knots. Volunteers keep them alive, firing boilers, swinging derricks, and teaching visitors how ordinary steel and ordinary people did an extraordinary job. They're time machines, oily, loud, miraculous. The Liberty ship wasn't a miracle product, it was a miracle process. America didn't outdesign the U-boats, it outscheduled them. Take a workable hull, simplify it, break it into modules, train a new workforce, and then learn ruthlessly every single day. Fix the steel, fine-tune the welds, organize the rail cars, keep the cranes fed, launch, repeat. That mindset built 2,710 copies of the same promise. This cargo will get there. In a war decided by logistics, fuel, food, trucks, ammunition, the steady arrival of slow ships beat the brilliant ambush of fast submarines. The Liberty program left more than museum pieces. It left a template for modern industry. When the stakes are high, build a system that gets better while it's running. That's how you turn a boxy steamship into a weapon, and a manufacturing method into victory.